Thank you very much, everyone, for joining today. So my name is Moyed Ismail. I'm a Senior Solutions Engineer at HashiCorp, based in Singapore. Please feel free to reach out to me. There's my Twitter handle if you need to get in touch. So today's discussion will be covering some of the patterns that are available to you for securing Terraform provider access to public cloud in Terraform Cloud. And we'll jump straight into it. There's actually quite a bit to cover. So we'll discuss what are the typical challenges with managing cloud credentials. Then we'll touch on Terraform Cloud and the patterns that are available to manage these cloud credentials for provisioning across public cloud. So I'm assuming that we all have a bit of a background on Terraform and how it authenticates. So the Terraform provider configuration requires some form of credentials that you would need to provision. In the case of the public cloud, I've listed in this table some of the methods that Terraform uses to authenticate to them. So in the case of AWS, you got your static IAM credentials that you would store in environment variables or configuration files. You could use IAM roles or instance roles. Now, in Azure and GCP, same concepts apply. They're quite similar. So with Azure, you have your managed service identity or service principals. And with GCP, you have the application credentials and so on. Now, a lot of the information I'm sharing, the patterns are actually transferable across these cloud providers. I'll be more focusing around AWS because of, I've played most with AWS, but a lot of the patterns are actually transferable, okay? Now, the challenges we have with managing these cloud credentials when we get started with Terraform, typically they're statically configured, right? And, they're stored locally on, your machine, or hard-coded in a pipeline or some CLI tools and scripts, right? And that obviously poses some challenges because you have sprawl of these credentials. They can be applied in different places, potentially shared between systems and users. And you also have, some of these credentials can be actually overprivileged. So you really kind of need to protect them. And, you also have the issue of them being long-lived. So I've worked, with a lot of, engineers where, ask when was the last time a credential was rotated, and, some of them have never done it, right? So a lot of these can pose a lot of issues. Now, specifically around Terraform Cloud, if you're not aware of it, it is a HashiCorp managed service that allows you to run Terraform on the cloud, right? And it has a lot of features that allow organizations, enterprises, and also individual developers and DevOps teams to, for example, manage their state files on Terraform Cloud, enable collaboration. Policy as code also is a feature that's available to you, and also things like around private module registry. Now, I recommend you go have a look if you haven't seen Terraform Cloud before, and that's the link there. Our primary focus will be around how do we manage cloud credentials in the Terraform Cloud Workspaces when we're deploying to the public cloud. Let's jump into the patterns. We'll cover 4. One is how do we use how do we protect static user, IAM static user credentials for deploying to, say, a single account, right? AWS account in this example. Then we jump into, once I've got these credentials, can I use them to deploy to multiple AWS accounts, right? And how do we go about doing that? That's another pattern. We can also use STS assume role. So we no longer need to create long-lived credentials. How do we use short-lived credentials that the cloud IAM providers offer us to update our workspaces and provision? And the last one is around Terraform Cloud Agent. So Terraform Cloud Agent is a feature of Terraform Cloud, and I'll touch on that at the end. And how do we use it with an instance role to do provisioning? There are many other patterns. So this is not an exclusive list. There is like many different other patterns, and you can actually use a combination of these to fulfill your needs. But we'll stick with those, and hopefully you'll get some insights there. So we'll jump on to the first pattern, which is around the static IAM user. Now, we have a Terraform Cloud Workspace. Now, what is a workspace? A workspace is hosts the Terraform state file with all the resources in it. So We have this workspace, and we need to be able to use this workspace to provision, do a plan and apply against a target AWS account. Now, the first thing we do is in this pattern is we create a user, IAM user, and we attach a network policy to it. Now, a good practice is to keep privileges to a minimal, so least privilege. This is for a networks team, so we're going to give them only network policy, provisioning VPCs and the like. Then what we do is we get those API keys, we go to the Terraform Cloud Workspace, and we create those two environment variables, the access key ID and the secret access key. And you can mark them as sensitive, and that's really important. I'll show you why shortly. Once we've done that, now that Terraform Cloud Workspace is able to provision against that target AWS account. What that looks like from a configuration perspective, you probably would have seen, if you're familiar with AWS UI, you probably would have seen this screen. So once you create the IAM user, you get the security credentials. That's from that security credentials tab, and the policy name that's attached, the network administrator. That's just an example. Obviously, you can create your own policy. And this is what the environment variables look like in TFC. And as you can see, they are marked sensitive. Now, why is this important, and how does it help secure those credentials? Once the credential is entered in as sensitive, you cannot extract it. So even if I'm a full administrator on that Terraform Cloud Workspace, I can never see that sensitive variable anymore. And that's quite powerful. The good in this pattern is it's very easy to set up, and it allows you to provision consistently to a single AWS account. It is secured by Terraform Cloud, the credentials, and they cannot be viewed by anyone, even by full administrators, they cannot be viewed. It allows for collaboration because you can have multiple contributors that are able to update Terraform configurations without needing their own cloud credentials. We're able to centralize those cloud credentials within Terraform Cloud Workspace. Now, the challenges are it could be difficult to scale, because if you have a multi-account structure, which a lot of organizations do these days, you would have to create an IAM user in every account, and then you'd have to get those credentials and store them into the workspace. So basically, this results in a higher administration, having to manage IAM users in this pattern. So what if we come across a situation where we need access to multiple accounts, AWS accounts, and we want to provision using that same static IAM user? What options do we have? Going back to that same example of the workspace, I have two accounts that I want to provision network services to, okay? Typically in a multi-account structure, you would have a central identity account. It could be the AWS organization account, or it could be another account within the organization that hosts IAM users or single sign-on, right? And we would create the TFC network user in that account, all right? And we would configure the assume role policy. So this policy allows this user to assume roles, and this comes very important shortly. I'll describe why. We would then create into every account a TFC network role. So basically you can bake in this role into every new account you would create, and you attach the network policy, right? Now, this assume role policy that's tied to the network user in the identity account needs to be able to assume into each of those roles. So what happens here is we've created the IAM user for that workspace. We provide the API keys, as you can see, to the environment variables. Then what we do, you can use variables like in a map, like say this map type variable that allows you to specify the ARN of the role, the target role you wish to use against the target account. So as you can see, I'm not sure if you can see my cursor, but you can see here the ARNs, and I'm creating aliases for each of those ARNs. And that allows me to specify the resource and what role I want to use for that deployment. And I'll show some configuration snippets on how that's applicable. So once we do our Terraform plan and apply, you're able to, the workspace is able to assume the role and deploy into it. So basically what I've been able to achieve is one set of credentials API keys, I'm able to deploy across multiple accounts using the assume role. In terms of what the configuration looks like, and then therefore I'm able to provision. What the configuration snippets here in the Terraform provider code, you would have this assume role. And within that, you can specify the role ARN. And as you can see previously, I've done a map of the variable. And this is how I'm referencing it. So network roles ARN, and I'm choosing the Singapore dev network role. And I'm tying it to an alias, which is the Singapore-dev-network. And the alias becomes very useful later when I specify or when I configure the resource. As you can see, I'm creating a provider for each of those roles, and I'm tying it to a different alias. So this role ARN in the variable map, I'm tying it to this alias, the Sydney-dev-network alias. All right. So this is an important concept for Terraform to be able to assume roles when it's provisioning. And in this example, I'm using this module to provision a VPC. And the VPC has this configuration called providers in it. All right. And here I'm able to specify the alias, the provider alias. So this Singapore VPC module, I'm going to use the Singapore-dev-network provider alias, right? Which allows me to use the role in the Singapore region or for that Singapore account. And now I'm able to deploy using that for the Singapore VPC. You could easily create another module, say, call it Sydney VPC, and use the Sydney alias as an example, right? And that will deploy to Sydney, all within the same Terraform configuration file. So the good in this pattern is all the benefits covered in pattern 1. So your static secrets, your API keys are locked away as sensitive in the workspace. No one else can see them. But also now you're able to scale the provisioning across multiple AWS accounts without creating additional IAM users. So you don't have to have this sprawl of different IAM users in every account, right? IAM roles do not expose any credentials. So I don't actually need to create credentials, feed them back to the workspace. Terraform knows exactly what to do with the assume role. And it's minimal and centralized IAM user credentials. I don't have this sprawl of IAM users and its credentials. Now, the challenges are, as you can see, the Terraform configuration file changes are required. So you need to actually specify the provider blocks and the aliases in advance. There's no way to do like a for each or a count. You cannot parameterize how the providers are created. You have to do them all up front, all right? And that's probably the key challenge. Now, we typically get a lot of practitioners asking us, okay, what if we need to rotate these cloud credentials, right? How do I, security team has come along and said, hey, API keys, fantastic. They're hidden, they're marked as sensitive, but how do I rotate them? They keep showing up if getting flagged, right? In our audit reports. And this is where using STS credentials. So this pattern's a little bit involved, so bear with me. The Terraform Cloud Workspace, I've created, there's 2 in this example. One that's managing the Sydney resources for this account. And I've had another workspace that's managing the Singapore region AWS account. Now, we spoke about the identity account and we had a TFC, the network user, if you recall. Now, I want to change that. I want to change that to STS short-lived credentials. What can I do? This is where HashiCorp Vault comes in. So HashiCorp Vault is a security tool that allows you to generate dynamic secrets. We have a secret engine called the AWS Secret Engine, and it allows you to generate just-in-time credentials against AWS roles. And I'll show you an example of that shortly. But the idea here is we want to now create a Vault user, IAM user, and configure the secret engine. And the cool thing here is the Vault user, once we generate the API keys, once they're locked into the Vault can actually rotate the secret ID. And basically no human knows what that secret ID is. Vault will manage it and it's never exposed. So we've taken care of the human element. Those credentials cannot be leaked anymore. Once we've done that, we create 2 roles. Each role represents the IAM role that's in the target accounts, all right? And the way I'll go through how Vault interacts or generates those short-lived credentials, but once we have the roles configured, if you notice, I've just added 2 more, a new environment variable called the AWS session token, and it's also marked as sensitive. So when you're dealing with STS credentials, this is another token you get as part of that credential generation. So I've added those environment variables. In this scenario, there's actually an external system. You may have an on-premise CI/CD tool, GitLab, GitHub, Jenkins, right? And you want to be able to, you have the requirement where you need to be able to rotate those credentials. So in this case, your CI/CD tool can actually request credentials from Vault. Vault will go out to each of those roles. If you recall, it has the ability to assume the role into each of those accounts. It will generate short-lived STS credentials and then pass them back to your pipeline. The pipeline can then orchestrate the upload of those credentials to your workspaces. And so Terraform Cloud has a rich API that allows you to interact with these workspaces in a pragmatic way, right? And in this way, you can schedule this to be done every 6 hours. I think the maximum STS credential you could have is up to 12 hours. So you could rotate every 6 hours, just-in-time credentials for every pipeline run. It's up to you, right? It's very flexible, very configurable. But the idea here is you're able to achieve rotation of the credentials and no longer you have those API keys. So once you've updated the environment variables, you're able to then provision against each of those target accounts, each workspace. Okay. Now, what does that look like from a Vault perspective? So Vault, I've created, we call them roles. So roles, you can name them anything you want. I've actually named them the same name as the workspace, the Terraform Cloud Workspace name. So for easy identification. And this is the role ARN, right? And that's what it will generate the dynamic credentials against. It's against this role. And it's an assumed role credential type. So I've done 2 here because I had 2 workspaces. Now, when I call to Vault to generate those credentials, what does it look like? So you can use the Vault CLI, you can use the Vault API, but you're able to use this endpoint for this role, and you can specify the time to live on those credentials. You could say, hey, I only want 15 minutes for this role credential. And you get back an access key, a secret key, and a secret token, right? And then you can feed those back into the Terraform Cloud environment variables. So what's the good here? Well, no hard-coded Terraform credentials anymore. You don't need, it's all dynamic and rotated. Short-lived, you can specify, the maximum I believe is 12 hours, but you can specify the length of time that you want for that run. Each role in the target account can be onboarded to Vault. So you could have hundreds of AWS accounts or any cloud accounts, and you want to be able to onboard them to Vault, all these roles, you can, right? And also Vault gives you the ability to revoke the credentials. So if there is a situation where you need to remove those credentials, it's just a command to Vault, you can revoke all these secrets. And so provides you maximum flexibility because it's within your pipelines. You can orchestrate the whole scenario. The challenge is obviously it's more complex, right? And it requires orchestration, typically with a CI/CD tool. And you need to note the time to live on the credentials for rotation, because if you miss to update the workspace credentials, if you do a deployment, it will fail if those credentials are no longer valid. Okay. The last pattern I wanted to cover is around TFC agents. So we have a scenario, what if there is a way I can get rid of completely of credentials in TFC? Is there a way to do that? And you can with TFC agent. So TFC agent is a feature of Terraform Cloud that allows you to deploy a Terraform remote worker in a private network, in your private network, right? So for example, you could have, again, in a multi-account AWS structure, you may have a common services account that hosts things like your Active Directory, your logging tools, anything like that. You could deploy the Terraform Cloud agent in there. You would deploy it, say, on an EC2, and there's a few different deployment options. You would attach an instance role to the EC2 that's running the TFC agent, and you would attach an assume role policy to that instance role. So now the TFC agent has the ability to assume roles into the accounts, right? Using AWS provided credentials using the instance role. So if we were to walk through what that looks like, the first step is when I deploy the TFC agent, I need to register it to Terraform Cloud. Once it's registered, the workspace, I'll configure it to only use this TFC agent, right? So any plans or applies that come after the fact will be sent to this TFC agent. Now, I need to differentiate which role I want to use. Now, we've covered this before. I'm using a map variable to with the provider aliases to configure which account I want to deploy to, all right? And I'm ready to do a run. So the remote runner will be on the TFC agent. The TFC agent will assume the role, and it will do the apply or the provisioning step into whichever account it is. So the good here is there's no Cloud Workspace credentials at all. I'm using cloud credentials, the IAM credentials, using the instance role in this case. The short-lived dynamic credentials, AWS is responsible for the rotation of those secrets, right? Or those credentials. And it provides the ability also to authenticate and provision to private infrastructure. You could have a hosted EKS that's in a private VPC or an AKS in the case of Azure. You could use this architecture to provision using Helm charts or, into that private infrastructure. So there's a lot of benefits in using a TFC agent in that scenario. I'm going to quickly just jump into a quick demonstration. I want to show you the third scenario around STS credentials. I'm not sure why I'm signed out there, but anyhow, so as you can see here, I've got this is Terraform Cloud, and the left-hand side I've got Vault. All right. Now, as here you can see the variables, and this is where they're stored. So I've called the Terraform variable network roles ARN, which what we've described. It's a HCL type, which builds a map. And this is where I'm specifying the alias that's going to be used and the ARN. And as you can see here in the environment variables, once I've locked in the secrets, right, I cannot view them anymore. So if I get edit, I'm full admin on this workspace. I cannot see it. So it's pretty much protected, right? Now, I just wanted to quickly show you where Vault comes in to generate dynamic secrets. So if you recall, I'm going to use for example, the Singapore region. I'm going to create a set of credentials, right? So I'll just generate that here. I'm not going to show you the secret key and the secret token. This is live. So I'm actually generating these credentials, which will be passed on to your pipeline. And then the pipeline will inject those into the variables here. Now, I've actually been, I've already have a Jenkins file that does this just to demonstrate. So I'm just going to quickly just kick it off. Oh, sorry, this is not the one. Apologies. All right, so I'm going to run this now. And what this build does, it actually talks to Vault. The pipeline talks to Vault. it authenticates, it will request a whole set of credentials for all these workspaces, and it will update them dynamically. So if you just recall the last 3 characters here, I just want to show you that it's actually been rotated. So once this pipeline completes, and here we go. So ZWD, so if I do a refresh on this workspace, NPH. So it's definitely changed. And now I have a set of credentials that will allow me to do provisioning, say for the next, I believe I set it for 15 minutes, the time to live on this. So as you can see, it's very powerful in terms of secret rotation and those credentials you can generate dynamically in this scenario. That's all I wanted to show you today. Hopefully you found it useful, and back to you, Peter.
Thank you, Moyad. We're just coming up to the hour, so we will close it out soon. I'm sure people need to move on, but thank you everyone for attending. I'm just checking the Q&A, Moyad. We do have one question here. If we are using TFC, does our Vault instance need to have public IP across, public IP so TFC can talk to Vault?
No, it doesn't. You can use, you can also use the TFC agent. If you have Vault in a private network, you could use the Terraform Cloud agent to interact with Vault in a private VPC or in a private network. You don't have to expose Vault, no.
And one other question, no agent available for use for encode API of TF, not cloud. It's in the Q&A section.
Okay, I believe, bear with me a sec, but yeah, I believe that the, so TFC, the agent itself is actually part of a subscription. So you actually have to subscribe to TFC, Terraform Cloud, to get access to the TFC, to the agent, right? So it's not from the free tier. Just wanted to point that out.
Okay, cool. Was the answer. So thank you, folks. We'll need to wrap it up now. We're at the top of the hour. But if you do, if you like what you heard today and want to learn more, we encourage you to go onto our Learn pages, which you'll find at learn.hashicorp.com on your screen there. And also, if you've got questions, further questions for Moyad, please reach out to him on moyad@hashicorp.com. And we do run these snapshots every fortnight. So if you have time, click on that link as well. But all these links will be provided in the follow-up email that I'll send to you all tomorrow, including a link to the recording. So thank you again, Moyad. Great job presenting and demoing. And for everyone on the call, thank you for staying to the end. I hope you got a lot out of it. Thank you for joining us today, and hope to see you on the next snapshot. Just checking to see we've answered all the questions in chat, none in Q&A, so we'll close it out now. Thanks again, everyone. See you on the next call.
Thank you.